Hello, my dear students. In last two classes, we have revised all the topics previous bridge. It was like a bridge course, whichever basics you have required. We have discussed all those things in our previous sessions. And from today onwards, we are directly starting with solution chapter. That is first chapter in your 12th standard. Okay. So, is my voice is audible? Yep, it is clearly audible. And let's start the session. And in between the session, if you have any doubts, if you come across any doubts, you can comment in the comment section. I'll go on clarifying your doubts also along with that. See, this is one of the very, very important and basic chapter also. Here, solution chapter, you will come across few terms, and important thing is colligative properties. Here you will get questions, problems based on colligative properties. First, we are learning basics of solutions. What are solution? Which are different types of solutions? And what are the factors that affects making a solution? All those the basic things we are going to study. And there are a few laws also. After that, two main laws are there. After that, we are going for colligative properties. Four colligative properties are there. In that, you have to learn equations and application of those equations in solving questions. Okay, so let us start now. What are these solutions? How can we define solution? Solution is a homogeneous mixture. How can we define solution? Solution is a homogeneous mixture. Homogeneous mixture of two or more components. Two or more components. Okay, see, it's a two homogeneous mixture. Here we are seeing one term, homogeneous. What is meant by homogeneous? Homogeneous means uniform composition. Uniform composition. So in a solution, two or more different substances will be there. Those substances will combine in a homogeneous manner. So such type of substances are called solutions. Solution is a homogeneous mixture of two or more than two components. And these components should be non-reactive. They should not react. So you can say it's a homogeneous mixture of two or more non-reactive components. You can also explain like that about solution. And see, in this chapter we are mainly concentrating on binary solutions. Binary solutions. Bi means two components. Only two components will be there. We are mainly studying about two component system. When two components are present, then they are called binary solutions. So here, what are the two components? Two components in binary solutions are solute and solvent. The first thing is solute and the second one is solvent. What is this solute now? Now imagine I'm preparing salt water. Okay, how do we prepare salt water? Salt will be taken and it will be added to water. Take a glass of water and add salt to it. Either add 2 grams of salt, 3 grams of salt, 1 tablespoon of salt, you can add to it. Now here among salt and water, what we are mixing? Salt plus water we are taking to make salt solution. Among salt and water, which one is present in larger quantity? Obviously it is water. We take water in larger quantity and salt will be added in less quantity, right? So that water, okay, that water which is taken in large quantity, or the component which is taken in large quantity, is called solvent. What is solvent now? Can we define solvent now? Yes, can we define solvent? What is solvent? Solvent is the component which is present in large quantity. Component present in large quantity. Component which is present in large quantity is called solvent. And another one, if one is large, another one should be in a small quantity. Here we are adding salt in small quantity. It's not like we take 1 glass of water and we add 1 glass of same salt to it. We never do like that for preparation of salt solution, isn't it? Here also in the same way, the one which is taken in smaller quantity. Component, sorry, okay, component taken in small quantity. Component taken in small quantity is called solute. I hope now you are clear with two components. One is solute, another one is solvent. Solute is the component which is present in small quantity, and solvent is the component which is present in larger quantity. So this is about basic things in solution. And one more thing, always remember, solution takes the physical state of solvent. Here we are taking solvent in large quantity. So what will be the physical state of solution? Always remember, solution will take the physical state of solvent. Why? Why? That's because solvent will be present in larger quantity. If solvent is water, sorry, solvent is in liquid state, then the solution will be in liquid state. If the solvent is in solid state, then solution will also be in solid state. If solvent is in gaseous state, then the solution will be in gaseous state. I hope you got this. Since solvent is present in larger quantity, solution takes the physical state of solvent. Okay. Now, based on physical state, solutions are mainly classified into three types. Based on physical state, solutions are classified into how many types? Three types. We know three types of states are there mainly: solid, liquid, and gaseous. So in the same way, based on physical state, these solutions are classified into solid solution, liquid solution, and gaseous solutions. Now let us study about these solid solution, liquid solution, and gaseous solutions one by one. So I'll start with solid solution. Now see, in solid solution, as the name indicates, it will be in solid state. We know the physical state of solution will be same as that of solvent. Physical state of solution will be same as that of solvent. So in all solid solution, what will be solvent state? In solid. Solvent will be in which state? Solid state. I hope you're understanding what I'm saying. In all solid solution, what will be the physical state of solvent? Solvent will be present in solid state, because solution takes the physical state of solvent. Now what about solute? Solute can be in solid state or solute can be in liquid state, or solute can be in gaseous state also. If we take solid solute and solid solvent, it becomes solid in solid. If we take liquid solute and liquid solvent, it becomes liquid in solid. If I take gaseous solute and solid solvent, then it becomes gas in solid. Okay, now let's study examples for all these things. If I take solid solute dissolved in solid solvent, which examples we can give for this one? Alloys, mainly alloys like brass, bronze. Alloys are mixtures of different metals, right? It's a homogeneous mixture of metal. So alloys are examples for solid in solid. One solid dissolved in another solid, solid solution. Okay. Now liquid in solid. Which example we can give? Amalgam. Do you know amalgam? What are amalgams? Tell me if you know the answer. What are amalgams? Comment the answer in comment section. Amalgam. Amalgam of sodium. Do you know what is meant by amalgam? Amalgam. Yes, hi Shankar. Okay. Yes, tell me what are amalgams? Any metals mixed with mercury is called amalgam. Sodium amalgam, potassium amalgam, like that. Sodium is metal. Mercury will be present in which state? Liquid state. So mercury and sodium. Here liquid is dissolved in solid. So this is example for solid solution where solute is liquid. Amalgam of sodium you can take. And last one is gaseous gas. Solute is a gas. Which example we can give here? See, in hydrogenation reaction, we use catalyst. Which catalyst we use in hydrogenation? Hydrogen in the presence of platinum, palladium or nickel. All these platinum, palladium and nickel, they are metals. When hydrogen is passed over that, they make a hydrogen will go into that metals and it makes a homogeneous solution. So we can consider example of gas in solid as H2 in palladium, or you can write H2 in platinum, or you can take H2 in the presence of nickel. All these examples you can give, or you can consider some dissolved gases in minerals also. Minerals contain dissolved gases. Those things also you can consider as example for gas in solids. Okay, I hope this one is clear now. Solid solution. In solid solution, solvent will be present in which state? Solid state only, and solute can be present in solid state, liquid state or in gaseous state. Now let's go to second type, that is liquid solution. In liquid solution, what is the physical state of solvent? In which state solvent will be present? Give the answer. Be quick. In which state solvent will be present? Obviously, the solvent should be present in which state? Liquid state. Solvent should be present in which state? Liquid state. And if I come to solute, what will be the physical state of solute? Solute can be present in solid state. Solute can be present in liquid state, or solute can be present in gaseous state. Okay, so solvent, solid solute dissolved in liquid solvent, or liquid dissolved in liquid, or gas dissolved in liquid. All these are examples for liquid solution where solvent will be liquid. The solute can be in any of the state. Let's go to example for this one. Solid in liquid. Which example? Simple example. Salt water you can take. salt water, or glucose water, sugar water, anything you can take. Okay, so salt and salt water, I'm writing only one example, you can make a list of this one. And liquid dissolved in liquid, ethanol in water, methanol in water, alcohol in water, ethanol in water. Ethanol is in liquid state, water is also in liquid state, both will mix to form liquid, liquid, liquid in liquid solution. And gas in liquid, any guess for gas in liquid? Aerated drinks, oxygen in water, all these are examples for gas in liquid state. Okay, so let me write aerated drinks, aerated drinks, or you can say solid in water also. Okay, I hope sorry, oxygen in water also, that's also example for gas in liquid state. So these are few things about liquid solution. And next let's check on last one, that is gaseous solution. In gaseous solution, what is the physical state of solvent? In gaseous solution, physical state of solution solvent should be gas. Solvent will be present in which state? Gaseous state. And if I come to solute part, solute can be here again, it can be solid or it can be liquid or it can be gas. Solute can be solid, liquid or gas. Solid in gas. Example for solid in gas, camphor. We know camphor, when it evaporates it goes to gaseous state, so you can take example of camphor in nitrogen gas, or iodine vapors in air also. Iodine is also volatile substance, it evaporates, it directly goes to gaseous state, so you can take iodine in air, or you can take camphor in nitrogen. Any example you can take. Or and next one is liquid in gas. Liquid in gas, which one? Humidity, where water will be present in air, humidity. Or chloroform mixed with gas, nitrogen gas. Chloroform will be in liquid state, it forms vapor, tiny vapors in nitrogen gas. Uh, that also can be given as example for liquid in gaseous state. And next one is, last one is gas in gas. Gas in gas, air. Air is a mixture of different gases, it's a homogeneous mixture. Air, oxygen, nitrogen, hydrogen, different gases will be present directly, right? Air there. So these are different classifications of solution based on physical state, that is solid solution, liquid solution and gaseous solution. In solid solution we have three subcategories, in liquid solution also three subcategories, and in gaseous solution also three subcategories are there. Now see, now here we have discussed different types of solution. We are adding solute and solvent. How much amount of solute is added? That's represented in terms of concentration. In your previous like lower standards, you have learned dilute solution and concentrated solution. Dilute solution is the one where, okay, we have learned about dilute and concentrated one. Dilute and concentrated solution. Dilute solution is the one where amount of solute particles will be less, and concentrated solution is the one where amount of solute will be more. But here we don't mention specifically how much amount of solute is present, how much amount of solvent is present. We don't mention that. So for that, now we are using different concentration terms. These concentration terms are nothing but They represent how much amount of solute is present in given solution or given amount of solvent. First, let us start with percentage composition. In percentage composition, first thing we have is mass percentage. It's very simple one. You have studied this in 9th standard. Mass percentage, as the name indicates, what will be there? Mass. We have two components. One is solute, another one is solvent. Together they make solution, right? So here in mass percentage, how do we calculate mass percentage? Mass percentage is calculated by the formula mass of solute, mass of solute divided by mass of solution into, we want percentage, so multiply it with 100. That's all. It's very simple one. Mass of solute divided by mass of solution into 100. It is represented by weight by weight. Mass percentage is represented by W by W. Weight by weight percentage. Mass, weight is mass of solute, and in the denominator mass of solution multiplied with 100. In 12th standard and all, you will not be asked to calculate mass percentage. In the question, how it comes is, for example, it will be like, the question will be like this: 10% of sodium carbonate solution, Na2CO3 solution. It will be given like this: 10% of sodium carbonate solution. How can I solve this one? How can, what I'll get from this? This indicates, this is nothing but 10 gram of Na2CO3, that is 10 gram of solute is present in 100 gram solution. 10 gram of, so 10% of sodium carbonate means 10 gram of sodium carbonate is present in its percentage composition. That means in 100 gram of solution. And what is the amount of solvent here? 100 is total solution minus solute gives the solvent amount, that is 90 gram of solvent will be present. Like this question will come, like in solving different questions, this sentence will be given. Based on that, you should be able to find the amount of solute present or amount of solvent present in that, mass of solute and mass of solvent in that. So this is mass percentage. If you go to volume percentage, how can I define volume percentage? What is volume percentage? Volume percentage. Volume of solute divided by volume of solution into 100. Volume percentage is represented by V by V. Volume of solute divided by volume of solution into 100. This indicates how much amount or how much ml of solute is present in 100 ml solution. That is nothing but volume percentage. And how it will come? For example, the question might come like this. In the question, it might be given, calculate 10% solution of ethanol in water. What does this indicates? 10% solution of ethanol in water. What this indicates? This is nothing but we have 10 ml ethanol in how much ml water? 90 ml water. And together they are making how much solution? 100 ml of solution. So this is what does this means, volume percentage. And next one is mass by volume percentage. How can we calculate mass by volume percentage? Mass in the numerator, mass should come, in the denominator volume should be there. This is nothing but mass of solute divided by volume of solution, volume of solution. The volume of solution should be in ml, remember, into 100. Mass of solute divided by volume of solution into 100. If it is given like 10% mass by volume of glucose, that indicates 10 gram of glucose is present in 100 ml solution, mass by volume. Okay, so this is how we define mass by volume percentage. And next one we have is, next concentration term we have is strength. How to calculate strength? What is this strength? What does strength means? Strength is nothing but, 1 minute. Okay, strength indicates mass of strength. Strength is equal to mass of solute in grams, mass of solute in grams present in 1 liter of solution. Volume of solution in liter, or in dm cube also you can take, both are same. So what will be the unit? Gram per liter. So how much amount or how much grams of solute is present in 1 liter of solution? That is nothing but strength. Okay, so this is how we calculate strength. I think in volumetric analysis, in practical part, you have learned this one. In acid base titration, you have calculated strength of given acid or strength of given base is equal to this much gram per liter. That is nothing but you are calculating how much gram of particular solute is present in 1 liter of solution. That is nothing but strength. Okay, next term is molarity. Next term we have is molarity. So what is this molarity? Molarity is represented by capital letter M. Molarity is represented by capital letter M. This is nothing but number of moles of solute present in 1 liter solution. What is molarity? Number of moles of solute present in 1 liter solution. So I can represent it like this. Molarity is equal to number of moles of solute divided by volume of solution in liter. Volume of solution in liter. See, if volume of solution is not in liter, if it is present in ml, then what will you do? Either convert it into liter or write it in ml, multiply the equation with 1000. Then it will get converted into liters. Okay. So what is molarity? Number of moles of solute which is present in 1 liter of solution is called molarity. So in simple way, I can write like this. Molarity is equal to number of moles of solute divided by volume of solution in liter. So how to calculate number of moles? What is the formula to calculate number of moles? Number of moles can be calculated by the formula mass by molar mass, where N is equal to mass by molar mass. That is nothing but number of moles. If you substitute that in the given equation, I'll get molarity is equal to number of moles of solute, sorry, which is represented by mass by molar mass, mass divided by molar mass into volume. If the volume is in ml, then what will you do? Multiply it with 1000. Okay, so this is the formula to calculate molarity. Or directly, if you remember number of moles by volume of solution in liter, that also works here. Okay, so that's nothing but molarity. You should know how to calculate number of moles in this one also. Next concentration term is normality. What is normality? Normality. Normality is represented by capital N, uppercase N, normality. How can I define normality? Normality N is equal to, it's nothing but number of gram equivalent. I'll explain what is this. It's nothing but number of gram equivalent of solute present in 1 liter solution. Number of gram equivalent of solute, N is equal to number of gram equivalent of solute divided by volume of solution in liter. Volume of solution in liter. What is this number of gram equivalent? How to calculate number of gram equivalents now? How we have calculated normality, sorry, number of moles? Mass by molar mass, right? Number of gram equivalent can be calculated by the formula number of gram equivalent is equal to given mass divided by equivalent mass. Given mass, that is nothing but normal mass by equivalent mass. Equivalent mass. Here one more thing comes, equivalent mass. How to calculate equivalent mass? Equivalent mass is nothing but equivalent mass is nothing but Hi Seventh Lokesh. Okay, equivalent, what is equivalent mass? Equivalent mass is equal to molecular mass divided by N factor. So what is this N factor? N factor is its basicity of acid or acidity of base or number of electron transferred or number the charge which is present. All those things represents N factor. For example, if I take H2SO4, H2SO4, here in H2SO4, it's an acid. What is the basicity of this acid? How many H plus ions it can donate? 2. So its N factor is 2. For this H2SO4, N factor is 2. And how to calculate equivalent mass now? Molecular mass. Molecular mass of H2SO4 is 98 divided by 2. This gives equivalent mass. 2 is N factor. 90 divided by 2 gives equivalent mass. And next go for number of gram equivalent. In the question, mass will be given. Mass of sulfuric acid will be given divided by its equivalent mass, which we get by dividing 90 divided by 2. That gives number of gram equivalent. Once you get number of gram equivalent, substitute that in the given equation. This is how you will calculate normality. I hope there is no doubt in calculation of normality. And one more thing you can calculate, normality can also be calculated, or you will get normality of solution by multiplying. Normality is equal to molarity into n factor. Molarity into n factor. This also gives normality. If you multiply molarity with n factor, you will get normality of the solution. And in case, if in the question it is given like semi-molar, can anybody tell me what is semi-molar? Semi means half, semicircle. We do like that, right? We say semicircle. What is meant by semi? Semi means half. Semi-molar or semi-normal means, here we are considering molar. Semi-molar means molarity divided by 2. Okay, semi-molar means m by 2. And one more, decimolar means, this is nothing but m by 10. M by 10 is nothing but decimolar. And centimolar means, centimolar. See, semimolar means 1 by 2 molar. 1 by 2. What is 1 by 2? 0.5. That is 0.5 molar. You can take like this also, 0.5 molar, if you are getting confused with 1 by 2 molar. 0.5 molar solution is called semimolar solution. And decimolar solution means 1 by 10. What is 1 by 10? 1 by 10 is 0.1. 0.1 molar solution is called decimolar solution. And centimolar solution means, what is centimolar solution? Centimolar solution means m by 100. 0.01 molar solution is called centimolar solution. And millimolar means, millimolar solution means m by 1000. 0.0001 molar solution is called millimolar solution. Remember these the four things in mind. Okay. Next one is molality. Previous one was molarity. Third one which we have studied, third concentration term was molarity, and this one is molality. What is the difference between molarity and molality? Molality is represented by lowercase m, that is small letter m, and this is given by the formula. Molality is equal to number of moles of solute, divided by mass of solvent in kg. See, be very careful. Molality is number of how many moles of solute is present in 1 kg of solvent. In the denominator we are taking solvent, not the solution. In all other previous concentration terms, just go through all the concentration term once. What was there in the denominator? Solution, volume of solution. Here also volume of solution, volume of solution, volume of solution. Solution was there, volume of solution, mass of solution, like this, isn't it? See here, mole fraction, sorry, In case of molarity, what we are getting? Mass of solvent is present. Mass of solvent in kg, that's given. So we should be very careful. Molarity is number of moles of solute present in 1 kg of solvent. Simple way we can represent it like this. Molality is equal to number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Or number of moles, how can we calculate number of moles? Mass of solute divided by molar mass of solute into mass of solvent in kg. If it is not given in kg, then multiply it with 1000. Remember, if it is not given in kg, you have to multiply it with 1000 if it is given in grams. Or you can directly convert it into kg and substitute in the equation. Okay, this is how you can calculate molality. And next thing is mole fraction. As the name indicates, it's mole fraction. 1 minute. Okay, it is mole fraction. Fraction of moles. If I am mixing two substances, imagine I am mixing 1 and 2. Two different components are there. We can calculate number of moles of first component as well as number of moles of second component. Mole fraction is represented by chi, symbol like this, and it is equal to, now I'll say mole fraction of first component. How many moles of first component are present compared to total number of moles of all the components present? So here number of moles of first component divided by total number of moles, N1 plus N2, since we have only two components here. If we have three components, then N1 plus N2 plus N3, like that. And mole fraction of 2 can be calculated by N2 divided by N1 plus N2. Number of moles of second component divided by number of moles of all the components present. So this is how we calculate mole fraction. And always remember, mole fraction of all the components, sum of mole fraction of all the components will be equal to 1. Here we have only two components, so sum of mole fraction of two components will be equal to 1. And if there are three components, sum of mole fraction of all the three components will be equal to 1. It will be like that. So this is mole fraction. And the last term we have is parts per million, which is represented by ppm. If the solute particles are present in very small quantity, or if the solute particles are present in very less quantity, then we represent the concentration in parts per million. We say, what is this parts per million? So mass, how much mass of solute is present in million parts of solution, or million gram of solution, that is nothing but parts per million. So we can represent it as ppm is equal to mass of solute or mass of any component divided by mass of solution into 10 power 6. This is how we get parts per million. Okay, so that's about different concentration terms which we have. And now see, we are mixing two different solutions. There are few things, or I have some components with term, I have some solution with molarity M1 and its volume is V1. Okay, what is the molarity of the solution? M1, and its volume is V1, and I'll dilute that. Okay, we are going to dilute that solution. After dilution, what will be the new molarity? New molarity will be M2. We don't know what is new molarity. And volume we know because we have added V1 was there. We have added extra water to it for dilution. Some new volume we get V2. How to find it? How to find molarity M2 for this? We have a formula for that one, that is molarity equation. If we dilute from volume V1 to V2, then we can write the equation as M1 V1 is equal to M2 V2. For dilution, which equation we use? M1 V1 is equal to M2 V2, where M1 is molarity of original solution, V1 is the volume of original solution, I mean in the beginning, and M2 is new molarity, V2 is new volume. After dilution, what is the total volume? And by knowing any three, you can calculate the other one. And next, if acid base reaction is taking place, if reaction is taking place between two solution, then how do we represent its molarity? How can I represent its molarity? First, you have to write the balanced chemical equation. You have to write balanced chemical equation. Then what will you do? How will you write? M1 V1 by N1 is equal to M2 V2 by N2, where N1 is stoichiometry, that is number of moles of first one component, one reactant present in balanced chemical equation, and another one is number of moles of another component, component 2 or reactant 2 present in the reaction. So that is nothing but N2. First, for this, what is important thing? You have to write the balanced chemical equation. Once you write the balanced chemical equation, you will get the value N1 as well as N2. It's not normality, don't get confused. Sorry, it's not number of moles, don't get confused. They are number of moles only, but you have to take this one, balanced chemical equation. In the balanced chemical equation, how many molecules are present? Stoichiometry of those reactants should be written in the place of N1 and N2. And when we are mixing two solutions, for example, I have two solutions. The solution 1 has the concentration M1 and its volume is V1. I am mixing it with M2 with V2. This is second solution. Second solution concentration is M2 and its volume is V2. And after mixing, they form new solution. Volume is V3. Volume is V3. V3 is nothing but V1 plus V2. Then how can I write the formula? How can I represent the formula? This can be, when we mix two solutions, we can find the new molarity by the formula M1 V1 plus M2 V2 is equal to M3 into V3. V3 is nothing but V1 plus V2. You can take V3 also, or you can take, just for your information, V1 plus V2 also. This is for mixing two solutions. Okay, now I hope you got about all the concentration terms. Now we have few problems for solving based on all these equations. Let's go through that problems one by one. First one, take a pen and notebook, start writing, start solving the questions, and once you get the answer, comment the answer in comment section. I'll start solving the equations or problems. First one, calculate the molarity and mole fraction. What we have to calculate? Molarity. M should be calculated and mole fraction should be calculated of ethanoic acid in 75 gram of benzene. 2.5 gram of ethanoic acid. See, 2.5 gram of ethanoic acid in 75 gram of benzene. One which is present in small quantity is solute, and the another which is present in large quantity is solvent. So here, what is mass of solute? Mass of solute is equal to 2.5 gram. Solute is present in small quantity, 2.5 gram, and ethanoic acid is our solute. What is the molar mass of ethanoic acid? Formula is given that CH3COOH. Molar mass of CH3COOH. This is equal to 60 gram per mole. 60 gram per mole. This is molar mass of ethanoic acid. Now come to solvent side. What is mass of solvent given? Mass of solvent, which is given as 75 gram. 75 gram is given. And what is the molecular mass? Benzene. Solvent is benzene. Molecular mass of benzene. What is the formula of benzene? C6H6. Molecular mass of benzene is 78 gram per mole. 78 gram per mole. Now we got mass by mass as well as molar mass of solute and solvent. So can we calculate number of moles of solute and solvent? Yes, obviously we can calculate number of moles of CH3COOH is equal to mass, given mass divided by molecular mass. 2.5 divided by 60. How much you will get? This is nothing but 0.0417. How much we are getting? 0.0417. This is number of moles of solute. And what about number of moles of benzene? C6H6. Mass 75 divided by molecular mass is 78, which is equal to 0.961. 0.961 you will get. Now I got number of moles of both solute as well as solvent. Next, what is asked to calculate? What we are supposed to calculate from this one? Molarity. 1 minute. See, sorry, this is not molarity. Calculate, take the question as molality. Change the question. Okay. Okay, molality. Take the question as find the molality. Small m we have to calculate. How can I calculate molality? We know the formula. Molality is equal to number of moles of solute. What is number of moles of solute? You have to write the formula. Number of moles of solute divided by mass of solvent in kg. So number of moles of solute is 0.0417 divided by mass of solvent is given. What is the mass of solvent in kg? It's given 75 gram. 75 gram is nothing but 0.075 kg, or 75 into 1000 also you can write. 75 in the denominator, multiply this equation with 1000, you will get the answer. So how much you get here? This is nothing but 0.55 mole per kg. Mole per kg, or you can write, instead of mole per kg, you can write small letter m mole. So this is nothing but molality. Okay, this is nothing but molality. And next we have to calculate mole fraction. Mole fraction of solutes should be calculated, or we can calculate for calculate the mole fraction of both also in the question. Okay, molality of mole fraction of ethanoic acid is given. So if we calculate mole fraction of ethanoic acid, that's enough here. So mole fraction of ethanoic acid CH3 COOH is equal to number of moles of ethanoic acid. How many moles of ethanoic acid are present? 0.0417 divided by total number of moles. Number of moles of ethanoic acid plus number of moles of benzene. 0.0417 plus 0.961. So this is nothing but, how much do you get? 0.0416. This is nothing but mole fraction of ethanoic acid. This is how you will calculate mole fraction and molality. These are very simple. Direct substitution is that. Next, come to second one. Calculate molarity and normality of solution containing 9.8 gram of H2SO4, that is sulfuric acid, in 250 cm cube of solution. First write the given things. What is given? Mass of H2SO4 is given. Mass of H2SO4, which is equal to how much? 9.8 gram is given, and volume of solution is given. How much is there? Volume of solution is equal to 250 cm cube. That is nothing but 250 ml, 250 cm cube in liter, because for calculation of molarity as well as normality we want solution, volume of solution in liter, right? So I'll convert this one into liter. 0.250 liter. Okay, then what else is given? Only these two things are given here. Now, do we know the molecular mass of H2SO4? Yes, we can calculate molecular mass of H2SO4. Molecular mass of H2SO4 is equal to 98 gram per mole. 98 gram per mole. Now, what I have mass of H2SO4 as well as molecular mass. Calculate number of moles of H2SO4 also. Number of, because for calculation of molarity as well as normality, we want number of moles of solute, which is equal to 9.8 mass divided by molar mass. 9.8 divided by 98, which is nothing but 0.1 mole. 0.1 mole. This is number of moles of sulfuric acid. Next, what is the next calculation? How to continue this? What is asked? Molarity. Calculation of molarity now. Molarity is equal to number of moles of solute. Here I have number of moles of solute, that is 0.1 divided by volume of solution in liter. That also here I have volume of solution in liter 0.250. So this is nothing but 0.4 mole per liter, or just you can write this one as 0.4 molar. This is the molarity. Okay. Next, come to normality. Next we are asked to calculate normality also. How to calculate normality? I'll tell you two techniques here. First, we want equivalent mass of H2SO4. Equivalent mass of H2SO4 is equal to its molecular mass divided by n factor. N factor in H2SO4 is 2. So 98 divided by 2 is 49. This is equivalent mass. And to calculate number of gram equivalent, number of gram equivalent is equal to given mass divided by equivalent mass. Given mass of H2SO4 is 9.8 divided by 49, equivalent mass, which is equal to 0.2 we get. 9.8 divided by 49 is 0.2. Now, normality. What is the formula to calculate normality? Number of gram equivalent divided by volume of solution in liter. 0.250, which is equal to 0.8 normal. This is how we will calculate normality. And one more formula we learned here, which is that I'll show you. See, normality is equal to molarity into n factor. Once you get the n factor in this one, here n factor is 2. So you can directly do, we know molarity here. Normality is equal to molarity, that is 0.4 into n factor. N factor is 2. That is nothing but 0.8 normal. Isn't the answers are same? Yes, instead of finding all these things, if you already have molarity, multiply it with normality, you will get the direct answer. I hope this one is clear for you. Go to next question. Calculate mole fraction of ethylene glycol. Formula is given for ethylene glycol and water in a solution containing 20% of C2H6O2 by mass. That is ethylene glycol by mass. Now write down the given things. What is given? 20% of ethylene glycol is given. 20% by mass. 20% by mass of C2H6O2, that is ethylene glycol. What this indicates? This indicates 20 gram C2H6O2 present in 100 gram. Another one is water. So 100 gram solution. 100 gram solution. So I got mass of solute now. Mass of solute is 20 gram. That's why we have discussed mass percentage in the beginning. Mass of solute is solute is ethylene glycol 20 gram, and molecular mass of C2H6O2, which is equal to 62 gram per mole. See, mass of solute is 20 gram. Mass of solution is 100 gram. What about mass of solvent? Mass of solvent should be 80 gram because 80 plus 20 gives 100 gram solution. Mass of solvent is equal to 80 gram. Okay. Now, which is solvent here? Water. Molecular mass of water is equal to 18 gram. Now calculate number of moles, because we are asked to calculate mole fraction. For calculation of mole fraction, we want number of moles. Number of moles of C2H6O2 is equal to given mass divided by molecular mass. 20 divided by 62. This is nothing but 0.322. And what about number of moles of water? H2O. 80 divided by 18. Mass by molecular mass. 80 divided by 18 is 4.44. Now, we got number of moles. It's very easy to calculate mole fraction now. Mole fraction of C2H6O2 is equal to number of moles of ethylene glycol divided by total number of moles. 322 plus 4.44, which is equal to, how much do you get? 0.068. This is mole fraction. And how to calculate mole fraction of water? H2O. 1 minus mole fraction of ethylene glycol, because we know sum of mole fraction of all the different components present will be equal to 1. Here we have only two components. We know the mole fraction of one component. 1 minus the mole fraction of that component will give the mole fraction of another component present. So 1 minus 0.068 is 0.93. This is mole fraction of water. So this is how we calculate mole fraction. I hope this one is clear. Let's go to last question. What is mole fraction of solute in 2.5 molar aqueous solution? What is mole? Be very careful. This is very simple question. Mole fraction of solute in 2.5 molar aqueous solution. First write the given thing. What is given? 2.5 molar is given. What this implies? This implies 2.5 moles of solute in 1000 gram of water. Aqueous solution is given. Aqueous means water. 1000 gram of solvent, because molality is nothing but number of moles of solute present in 1 kg of solvent. 1 kg means 1000 gram. 1000 gram of solvent. This is given thing. And what is the mole fraction? We have to calculate. So mole, I already got number of moles of solute. Moles of solute is equal to 2.5. How to calculate moles of solvent? Moles of solvent is equal to, we know the mass of solvent 1000 gram given, divided by molecular mass 18. So 1000 divided by 18 is 55.55. This is number of moles of solvent present. Now calculate mole fraction. Mole fraction of solute is asked. Solute is equal to number of moles of solute divided by total number of moles, 55.55. This is nothing but 0.043. So this is mole fraction of solute. So this is how you will solve this question. It's very simple one, and I think we have covered most of the things in this. Next we have solution, like we have to study about solid solutions and liquid solution, how factors affect them. That we are going to discuss in our next class. I hope nobody have doubt in this one. So if anybody have doubt, if you get doubt while reading this one, or if you couldn't solve any question, let me know the questions in the comment box. I'll answer your questions. Okay, so till next class, have a good time, read well, prepare well, and come.